America is building solar faster than it is rebuilding the factories behind it. In 2026, thousands of new solar projects are moving across the grid, from Texas and Arizona to Georgia and the industrial Midwest. On paper, it looks like an energy success story. More power, more clean electricity, more capacity for data centers, factories, and a growing economy. But behind every solar farm is a hidden question most people never ask. Who actually built the hardware? Who made the cells inside the panels? Who controls the wafers, the inverters, the transformers, the batteries, and the supply chains that make the entire project possible? Because America may be winning part of the solar build-out race, but it is still fighting to control the factory race underneath it. And that race may decide who holds real power in the next energy economy. For American viewers, this matters because the grid is no longer just a background system. It is becoming the foundation of economic power. Every new data center needs electricity. Every new semiconductor plant needs reliable power. Every reshored factory, battery plant, warehouse network, and electrified industrial process depends on the same thing: a grid that can expand fast enough to keep up. For decades, U.S. electricity demand was relatively flat. That period is ending. AI data centers are becoming major power customers. Manufacturing policy is trying to bring strategic industries back to American soil. Electrification is changing demand from transportation to buildings, and extreme weather is making reliability more valuable, not less. That creates a difficult problem. America needs new power quickly, but it also wants that power to be secure, affordable, and not overly dependent on foreign industrial systems. Solar is attractive because it can be deployed in large volumes. It can be built in utility-scale projects, commercial rooftops, community solar arrays, and distributed systems. It can help meet daytime demand, reduce fuel exposure, and support new industrial loads when combined with batteries and grid planning. But if solar becomes one of America's fastest ways to add power, then solar equipment becomes strategic infrastructure. That changes the entire meaning of a panel. A solar module is not just a commodity product sitting in a field. It is the visible end of a manufacturing chain that starts with purified silicon, moves through ingots, wafers, cells, modules, power electronics, mounting systems, substations, software, and grid connection. If too much of that chain sits outside the United States, then the energy transition creates a new kind of dependency. Not oil dependency, clean tech dependency. And this is why the 2026 solar build-out hits America in a much bigger way than most people realize. It is about power prices, but also about factories. It is about emissions, but also about energy security. It is about construction, but also about whether the United States can rebuild an industrial base around the technologies that will power the next economy. The country that wins the solar race will not simply be the country with the most panels. It will be the country that can build, finance, connect, and manufacture them at scale. To understand the factory race, you have to understand what a solar supply chain actually is. Most people see the module, the finished panel installed on a rack in a field. But that panel is only the final visible layer. Before that, there is polysilicon. This is highly purified silicon, refined to the quality needed for solar manufacturing. Then the silicon is formed into ingots and sliced into wafers. Those wafers become the base material for solar cells. The cell is the electrical heart of the panel. It is where sunlight is converted into electricity. Cells are then assembled into modules, laminated, framed, tested, and shipped. But even that is not the whole system. A solar farm also needs inverters to convert DC electricity into AC power. It needs trackers or fixed racking systems. It needs glass, backsheets, junction boxes, cables, transformers, switchgear, substations, communication systems, and often batteries. Then comes the hardest part: connecting the project to the grid. This is why solar manufacturing is not the same as simply assembling panels. A country can have module factories and still depend heavily on imported cells. It can have cell production and still depend on imported wafers. It can build projects quickly and still wait years for transformers or interconnection approval. That is the uncomfortable reality inside America's solar boom. The United States has made real progress in module assembly. Domestic factories have expanded, and federal tax credits have encouraged companies to build more capacity in the U.S., but upstream manufacturing is harder. Cells, wafers, ingots, and polysilicon require deeper capital investment, technical expertise, reliable demand, and long-term policy certainty. This is why one factory in Georgia matters more than it may appear. When Q-Cells began producing solar cells in Cartersville, Georgia, it was not just another factory announcement. It represented an attempt to close one of the most important gaps in the American solar supply chain, the gap between making panels and making the critical components inside them. For years, the United States could assemble modules while still relying on imported cells. That helped domestic production grow, but it did not fully solve the dependency problem. A panel could be assembled in America while the most important upstream steps happened somewhere else. That is why the phrase "made in America" can be more complicated than it sounds. If the cells are imported, the wafers are imported, the polysilicon is imported, or the manufacturing equipment is imported, then the supply chain is still exposed. The factory race is not about one label. It is about how much of the system America can actually control. And that is where the conflict begins. Solar developers want cheap equipment. They need bankable suppliers, predictable delivery schedules, and project economics that work under real financing conditions. If modules are too expensive, projects become harder to build. If equipment is delayed, power purchase agreements get stressed. If uncertainty rises, capital becomes more cautious. Domestic manufacturers want something different. They need stable demand, clear rules, protection from unfairly priced imports, skilled labor, and confidence that the policy environment will not shift before their factories reach scale. Those two priorities are not always aligned. Cheap imports help America build solar faster. But if imports are too cheap, domestic factories struggle to compete. Protection helps manufacturers invest. But too much cost pressure can slow deployment. America is trying to do two things at once: build solar as fast as possible, and rebuild the industrial base behind solar at the same time. That is extremely difficult. It means the United States is using tax credits, tariffs, domestic content rules, trade investigations, and industrial policy to reshape a supply chain that was not built overnight. China spent more than a decade scaling solar manufacturing into a deeply integrated ecosystem. It has scale, suppliers, workers, factory equipment, logistics, and price power across multiple stages of the chain. America cannot replicate that instantly. And because China's role in global solar manufacturing remains so large, every U.S. policy decision creates tension. Raise tariffs and you may protect U.S. factories, but you may also raise costs for developers. Tighten import rules, and you may reduce exposure to forced labor or unfair trade practices. But you may also create delays, support domestic factories, and you may strengthen long-term energy security. But you still need enough near-term supply to keep projects moving. This is the central conflict of America's 2026 solar build-out. The deployment side wants speed. The manufacturing side wants durability. The national security side wants control. And the grid needs all of it to work at the same time. This is why the solar build-out is becoming a stress test for American industrial strategy. It asks whether the United States can move beyond being a buyer of clean technology and become a builder of clean technology again. But the factory race is not only domestic, it is geopolitical. In the old energy world, power came from fuel. Countries competed over oil fields, gas pipelines, shipping lanes, refining capacity, and strategic reserves. In the new energy world, power also comes from factories. The country that controls the production of solar cells, battery materials, grid equipment, electrolyzers, semiconductors, and power electronics has leverage over the countries trying to deploy those technologies. That does not mean solar is bad, it means solar has become strategic. If the United States builds a huge clean energy system using components it cannot reliably produce, it shifts one form of dependency into another. Instead of depending only on fuel imports, it may depend on manufacturing imports. This is especially important because electricity is becoming more central to national power. AI needs electricity. Defense manufacturing needs electricity. Semiconductor fabs need electricity. Ports, logistics, water systems, and communications networks all depend on a stronger, more resilient grid. So the question is not just whether America can build enough solar. The question is whether America can build a solar industrial ecosystem that includes manufacturers, mining and refining capacity, skilled labor, engineering talent, permitting systems, transmission planning, interconnection reform, battery deployment, and long-term demand from utilities and corporations. It also includes allies. South Korean, Japanese, European, and other allied companies may become important partners in reducing dependence on Chinese-dominated supply chains. The Georgia example shows how allied capital and American industrial policy can combine to create domestic capacity, but it also shows that the U.S. factory race is not purely national. It is a networked competition, where allies, trade rules, and investment incentives all shape who builds what and where. At the state level, this creates another race. Georgia wants factories. Texas wants power and industrial growth. Arizona wants solar and batteries. Michigan wants manufacturing. Other states want the jobs, tax base, and supply chains that come with the clean energy build-out. The result is a new map of American energy power, not just oil states and gas states. Solar states, battery states, factory states, grid bottleneck states, and interconnection states. This is where renewable energy becomes industrial geography. But there is an important nuance. America cannot rebuild the entire solar supply chain overnight, and pretending otherwise would be unrealistic. Upstream manufacturing is capital-intensive. It requires specialized equipment, trained workers, process expertise, and large-scale demand. It also faces price competition from countries that already operate at enormous scale. Imports are not automatically the enemy. Without imported components, America's solar build-out would likely slow down. Strategy has to balance deployment speed with supply chain security. The goal is not instant isolation. The goal is resilience. That means using imports where necessary, while building enough domestic and allied capacity to avoid permanent dependence. It means recognizing that the cheapest panel is not always the safest long-term strategy, but also that expensive domestic equipment cannot succeed unless projects still make economic sense. There is another nuance too. Solar alone does not solve the grid. A massive solar build-out still needs batteries, transmission, transformers, substations, dispatchable resources, demand response, and smarter grid operations. Without those pieces, solar can run into curtailment, congestion, and interconnection delays. So the factory race cannot stop at panels. If America builds panels but lacks transformers, the projects still wait. If America builds solar farms but lacks transmission, the power gets trapped. If America builds daytime generation but lacks storage, the system still struggles in evening peaks. If America builds hardware but lacks skilled electricians, engineers, and construction crews, deployment slows anyway. The real strategy is not just solar manufacturing, it is energy system manufacturing. That is the larger lesson of 2026. America's solar build-out is revealing the difference between an energy transition and an industrial transition. An energy transition asks, how do we generate cleaner electricity? An industrial transition asks, who builds the machines, controls the supply chains, trains the workers, finances the factories, connects the grid, and captures the economic value? That second question is now unavoidable. For years, solar was framed mainly as a climate technology. Then it became a cheap power technology. Now it is becoming an industrial strategy technology. And that changes the stakes. If America succeeds, the solar boom could support a broader manufacturing revival. It could create more resilient supply chains, reduce exposure to geopolitical pressure, and help power the next wave of industrial growth. If America fails, it may still build a lot of solar, but remain dependent on the industrial base of its competitors. That is the uncomfortable possibility. A country can install the future without manufacturing it. And if it does, it may gain electricity, but lose leverage. The first solar race was about making panels cheap. China largely won that race by building scale faster and deeper than anyone else. The second race is different. It is about making solar strategic, secure, and industrially resilient. That race is now happening inside the United States, in Georgia factories, Texas solar fields, Arizona battery projects, Michigan manufacturing plants, port terminals, substations, permitting offices, and corporate power contracts. The panels may be installed in deserts, on farmland, beside data centers, and across industrial sites. But the real battle is being fought inside factories. Because in the next energy system, the countries that manufacture the hardware will not just supply the transition, they will shape the balance of power.